Hello everyone, welcome to my study channel Chemistry. Subscribe my channel and press the bell icon to get more new updates. Thank you. So today we will discuss one new chapter and the chapter is coordination compound. So we all have seen some compounds in chemistry. Some compounds have been written as NiH2O whole 6 Cl3 or written COH2O whole 6 Cl2 like this way, where one third bracket portion is there. Within the third bracket some species are present and outside the third bracket one species is present. So this type of compound we usually say these are coordination compound. Now say within the third bracket this part we call coordination sphere. We call it coordination sphere, and outside the third bracket part we call it ionization sphere, or we also say counter ion part. Okay, now if we write this compound like this way, CO 6H2O is present, right? So H2O, then H2O, 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 4H2O, complete, 2 more, H2O, H2O, right? And outside the coordination sphere 2 chlorine, so Cl2. So now you can see there is a coordinate bond between H2O and cobalt. So 6 coordinate bonds are here. That's why this portion is called coordination sphere, because here coordinate bonds are present, right? Now outside the coordination sphere we call it ionization sphere. Why? Because this part can make ions. Now the ligand. Now the question is, what is ligand? See, the species which is directly attached with the central metal atom through coordinate bonds. That species is called ligand. So what is ligand? The species that one is directly attached with the central metal atom through coordinate bonds are called ligand. Here in this compound the ligand is H2O. This ligand part has primary valency, and the counter ion part which is attached with the central metal atom through ionic bond, that counter ion part has primary valency, that is 1 degree valency. So the counter ion part has 1 degree valency or primary valency, and the ligand part which is attached with the central metal atom through coordinate bond, that one is 2 degree valency or secondary valency. Now there is another term, that one is coordination number. What is coordination number? The coordination number is the number of coordination bond that one is present within a coordinate compound. So what is coordination number? Coordination number is the number of coordinate bonds which is present in a compound is called coordination number of that compound. In this case here total 6 coordination bonds are present, so the coordination number of this compound is 6. Another term is denticity. So the question is, what is denticity? So denticity is the number of coordination bonds forming by a ligand at a time in a compound. Again I am repeating. Denticity is the number of coordination bond that one is forming by a ligand in a compound at a time. So here you can say 1H2O is forming one coordination bond with the central metal atom, right? 6H2O molecules are present here, and 6H2O molecules are forming 6 coordination bonds with the central metal atom, right? So each H2O is forming one coordination bond. So H2O, denticity of H2O is 1. Now if any ligand has denticity 1, then that ligand is called monodentate ligand or unidentate ligand. If the denticity is 1, then it is called monodentate or unidentate ligand. If the denticity is more than 1, then it is called polydentate ligand. Okay? If it is more than 1, then it is called polydentate ligand. Now, in this polydentate ligand, it may be bidentate, tridentate, tetradentate, pentadentate. If 2 denticity, then bidentate, 3 denticity, then tridentate, 4 denticity, then tetradentate. Like this way it will go on. For example, we can write one unidentate ligand H2O, which is present in this compound. One H2O is forming one coordinate bond at a time within a compound. So denticity of H2 is 1. So this is monodentate or unidentate. Now bidentate ligand, we can write this is bidentate ligand ethylene diamine. In short, we can write EN. We have oxalato. This is also polydentate ligand. Then we have glycinato. In short, we can write gly. This one is oxalato. In short, we can write OX, gly. Now you just see, in these two cases, you can divide them into two symmetrical parts, to two identical parts, right? If you divide them in this way, then you will get two identical parts. So these two ligands we call symmetrical ligand. And this one you can't divide it to get identical part, so this one is unsymmetrical ligand. So this is the first part of the coordination compound. I hope this is helpful for you all, and if you like it, please don't forget to like, share and comment, and also subscribe my channel.